So in this video, we're just doing a full example of what we were learning about a sampling distribution of a proportion, also applied to more of a real-world example and no longer looking at just beads. So let's read our story problem here slowly and pull out the important information we need as we go. So, suppose that a certain college currently rejects 31% of all applications. Just looking at that first sentence, I know a couple of important things. One, I do actually know that I'm going to be working with a categorical variable. We're looking at rejecting applications. So if I were to ask, was your application rejected, what are your possible answers? Yes or no. So it's a categorical variable since we're falling into one of those two categories. Next, I know that I have this 31% and I need to figure out what that's going to represent for me. So that 31% is going to be a decimal of 0.31, but I need to figure out if that's going to be a sample proportion or if it's going to be a population proportion. So what applications are we talking about? Well, it says all applications. So that all is going to help me realize that that's going to be a population proportion, or that my P is going to be 0.31. Alright, next, we decide to take a systematic sample of every 50th application and record whether the student was rejected or not. Two things I know after that sentence. I know about my sampling method, so that's going to help me figure out if I believe it's actually unbiased or not. Secondly, I would also know at this point that, again, it was a categorical variable if I didn't realize that or not, because it says we're going to record whether the student was rejected or not. So they're going to fall into one of those two categories, rejected or not. Finally, this resulted in a sample size of 341 people. So our sample size, symbol-wise, is our n. So I also know that my n is going to be 341. Alright, so first we're going to go through and find our sampling distribution, which does include here to check our conditions. So our conditions that we have. We need to have our relatively random and unbiased sample. Specifically here, we were actually told that it was a systematic sample of every 50th application. So it sampled and sampled every 50 after that. So at least from what I know, that's not a bad thing. So I'm going to say that there really does not appear to be any bias associated with that. Next, we need to check our n times our p to check if it's at least 10. So our n we already have labeled up here as our 341. Our P is our 0.31. And if we do our math there, we get 105.71, which is at least 10. Now, just make sure you can do the math, but if you want to understand what that number just checked, is that if we reject 31% of all applications. If we sampled 341 applications, we're going to expect roughly 105.71 or 106 of them to be rejected then. Our third condition is checking that our n times 1 minus p is also at least 10. So this time we get 235.29. which is also at least 10. And this number would represent how many we would expect to not be rejected. So of our 341 applications, we expect roughly this 106 to be rejected and the other 235 to not be rejected. So our conditions are met. So we will be able to say then that our p hat will be approximately distributed normally. My mean of p hat is just my p, so that's our 0.31. And our standard deviation of p hat is our square root of p times 1 minus p over n. So I need to do the math here. Which gives me 0.0250. Now generally, to emphasize here, if math goes wrong, it's generally here in that standard deviation calculation. The most common thing to do is actually forget the square root part, because many calculators have you do that part last. So definitely make sure that you are getting the same numbers that we are when you do the examples. So this is our mean, this is our standard deviation. We're going to use that as we move to the next part, looking at our normal curve rule, that 68, 95, 99.7 rule. So we need our mean, which will go in the middle there of our 0.31. And then we're going to go up to 3 standard deviations out. Here our standard deviation is the 0.025 that we calculated above. And then just doing our math for those, that's going to be 0.285, 0.26, 0.235, 0.335, 0.36, and 0.385. So when I go out that first standard deviation, that's my 68%. When I go out my second standard deviation, that's our 95%. And when we go out that third standard deviation, we get the 99.7%. Right, we're also going to interpret what we expect here. You do have a couple of examples of that, so it might be good to actually pause the video here and try it on your own first to see if you get the same interpretations that I do. So let's see how we did. So we're sampling 341 applications. 68% of the time, we should find that between 28.5% and 33.5% of them are rejected. When sampling 341 applications, 95% of the time, we should find that between 26% and 36% of them are rejected. And finally, when sampling 341 applications, 99.7% of the time, we should find that between 23.5% and 38.5% of them are rejected. So again, now we have an idea of what to expect. So do you think it would be very unusual for me to find that 35% of the applications are rejected? Well, that's in here. It's within that 95%. What if I said, do you think it'd be very likely for me to find that 20% of the applications are rejected? Again, that's way outside of here. It's not even on my picture, so that is definitely not very likely to happen. So that's what this sampling distribution allows us to have an idea of what types of values to expect, which ones are likely to happen, versus the further away I get here, the more unlikely they are to happen. All right, let's continue this problem by calculating some probabilities. So we want to find the probability that no more than 79 of our 340 applications were rejected. Well, I'm going to start by just putting my numbers along the bottom here that we just calculated in our previous example. So we have that. Next it says no more than 79 of these 341. Well, I need a p hat to put on my picture. P hat is my sample proportion. So I've got to take that 79 out of our 341, which will give us a sample proportion of 0.2317. So where is that on my picture? It's just a little bit smaller than this 0.235 number. So there's our 0.2317. And the fact that then it says no more than, so this would be the largest number it is. So that technically means we're going to shade everything smaller to the left of it. So I can already tell from my picture this is going to be a pretty small number. Now let's think through what we've also learned in Module 1. So looking at my picture here, would I have to use a rule on this, or the number from the table give me my answer? Well, remember, the table is shaded left. My picture is shaded left. So I'm going to be able to go straight to the table to get my probability. Next, it's kind of nice to have an idea of what your z should be when you do your calculation. So as a reminder here, and I will erase these here in a moment, this z right in the mean would be 0. This will be a -1, and this will be a 1, because this one is one standard deviation above the mean, so it's positive. This will be a -1 because it's one standard deviation below the mean. This would be -2. This would be -3. This would be +2. That would be +3. So what I can tell before I even do my math for my z-score is that I should get a z even smaller than -3. So let's do the math, and then I'm going to erase those numbers so we don't have too much going on here. So if I look at my z formula, so it's p hat minus p over the square root of p times 1 minus p over n. We have our p hat, it's that 0.2317. We have our p, that's our 0.31, or the number here that's in the middle. And then we need to divide by our square root of p times 1 minus p over n, which is also our standard deviation, which we calculated here to be our 0.025. Remember, that's also the size of the increment, the distance between these two numbers here. And so when I do that, I get a z of -3.13, just as I expected it to be even smaller than -3. I'm going to erase those little blue numbers just so they're not there to confuse us. All right, now we're going to take that number to our table. -3.13. So again, up to the first decimal point is the row. Second decimal point is our column. So here's our -3.1. And then 3 was our column. So this is going to line up at this 0.0009. Now remember, the table is shaded left. Our picture is also shaded left. So this number is also our probability. I didn't need to use our 1 minus rule here because it was not shaded to the right. So that's all the math with this problem. All we have left is the interpretation. And I'll try to sort of block this off here a little bit for us. So if 31% of all applications are rejected, because that is what they told us at the very beginning of the problem, And this is basically saying we're going to use a P of 0.31. The probability that that no more than 79 of the 341 applications were rejected is our 0.0009, or if you're asked for a percentage, multiply by 100%, and that would be 0.09%. All right, all that's left here is doing another probability calculation. So it's always a good thing here after we do one to pause the video and try this next one on your own first and then see if we match. So again, pause the video. So first, here's what my picture looks like. So same numbers along the bottom here in black as we had above. But this time my p hat is the 125 out of the 341, which gave me 0.3666. I do usually try to carry at least 4 decimals with me. Where that is on my picture, it's a little bit to the right or above 0.36. So again, here, if I'm thinking about my picture before I dive in and do the math. So this time my picture is shaded to the right, my table is shaded to the left, so I know I'm going to have to use that 1 minus rule on this example. Secondly, I also know that this time my z is going to be between 2 and 3. So somewhere between 2 and 3 for my value of z. All right, hopefully that part matched. You can try pausing here again if you mess something up to continue, or keep watching the video. All right, so here's all of my math done. So my z, I'm using the same formula that we used above. So notice the only thing that changed is our value of p hat. Both p and our standard deviation are exactly the same. Just as I saw, my z is going to be between 2 and 3, so it's a little bit more than 2, but smaller than 3. I took that value to my table. So this time our 2.2 was our row and 6 was our column. So I got that 0.9881 number. But then again, that's telling me it was to the left of that number. So again, technically that is this piece if I want to put it on my picture. So I had to use the 1 minus rule to get my actual probability. So math-wise, being totally done, our answer is 0.0119. If you already want to think about that in percentage form, multiply by 100%, that's going to be 1.19%. The last thing here to do is to interpret it. So let's see if that part matches. So following a similar from above, so if 31% of all applications are rejected, p is still 0.31 as it was above, then the probability that at least 125 of these 341 applications were rejected is our 0.0119, or which is 1.19%. All right, so hopefully these examples will get you started. If you have questions, feel free to post those on the discussion board or send an email.